Welcome, my name is Stefan. I'm working for MSG since 2004. And my major hobby is everything which is related to smart home and automation of things and tasks. And today I want to share my experience with voice assistants and tell you how you can develop new features for these devices. Before we start, I'm interested how much people in this room contains a voice assistant. Okay, someone. Okay, then let's start. Currently there are two big players on the market for voice assistants. The leader is definitely Amazon with his Alexa ecosystem, but also Google is fighting really hard for new customers and for his Google Home device. You see it on this picture. 2017 was a big milestone for voice recognition and the corresponding devices. Amazon currently has 70% of the market, and here you see how the number of sold devices has risen in the last year. Especially at Christmas season, these devices were a very popular present. And there's a statement from Google which says, in each second they sell one Google Home. And for Amazon Echo, the Echo Dot device is the most popular device on the complete Amazon platform. Here you see how the downloads of the Alexa has risen in the Christmas season. And this, when you think about the history of voice recognition, the history was not really good when you think about 10 or 15 years ago. But today, with much powerful standard features, voice recognition comes more and more state of the art. The standard features, I think everyone in this room knows the features, are playing music, setting timers, telephone and smart home features, and also lists, shopping lists, or general asking questions. These are very popular, and the reason why these devices are so popular. But I think everyone in this room knows the standard features, and I want to talk about how you can add new features. Before we start with the technical stuff, I want to clarify some points. For when we are talking about Alexa and new features for Alexa, we are talking about Skills. So Amazon is not using the term app. Google Assistant switched to the term app some months before they used Google Assistant services. And this old term you can find in many documentations till now. For the Alexa, there are very many Alexa skills available, over 20,000 at the end of the last year. For Google Assistant, you see there are not so many third-party apps. But the number of apps or skills are not a real indicator about the quality. And to be honest, the most of the Alexa skills are not really helpful. Many people ask me always, can I earn money with that stuff? The short answer is not really, currently not. For Amazon Alexa, each skill is generally free. You can do it or handle it completely by your own via enabling account linking. So when the user wants to activate the skill, he needs credentials of you. But you have to handle it completely by your own, and it's definitely not standard. There are some programs from Amazon where Amazon pays the developer for very popular skills. But these programs are not really documented, and when you check the site on the Amazon page, there are only statements like, we, Amazon, will inform you when you have a very popular skill, and we will inform you how much money you will get. And they are not really examples, how much user do I need to earn 100 euros or something like that. And especially in Germany, I think this is very restricted, because in Germany you doesn't have so a big user group as in the USA. There is also a program which helps you to reduce the costs, because in theory, when you are hosting a skill, this could, in theory, lead to costs. But this is more a theoretical problem, and in the practice you have a free tier, which normally leads that you doesn't have to pay something. So it's more a marketing point of view, in my opinion. For Google Assistant, I couldn't find any information like that, and I don't think that you can earn money currently. But both companies are working hard for a new concept, and I'm very sure that in the future you can earn money with that. In general, I think when you think about to develop new features for voice assistants, you shouldn't have the money in mind. Either you do it for free to learn a lot about cloud computing, or you have a company behind you, and this company wants to support this voice assistants. Because when you don't support it and you have a use case which is perfectly for voice assistant, you have always the risk that another company handles this use case and you will lose users or customers. So don't ignore this topic only because you can't earn money with that. Currently, nearly 90% of the users knows that there are more than the standard features and already use third-party skills and apps. So if you develop something which is helpfully, the potential that you have many users is really high. Before we are talking about the technical stuff, I want to talk a little bit about the user experience. Because the user experience is very special for voice user input. When you compare it to a smartphone app where you have a button, the user has to press this button. But for voice user input, there are many different phrases which can trigger the same action. And you should support as many as possible. Some people are more asking the voice assistant, like, can you tell me the weather? Some kind of people are giving more commands. Some kind says please, someone says not please. This is only an example. And the next thing is you should always keep the response of the voice assistant, the spoken response, very shortly, because otherwise it's getting annoying, the user. You should avoid repetitions in general, and you should think about intelligent guiding. When you have an experienced user, he doesn't need a big guiding through the conversation because he knows what the assistant is expecting from him. And a very interesting point is you should try to repair broken conversations. So when the voice assistant is asking the user something and the user doesn't answer, don't know why, silence on the human side, then you should not break the conversation now. You should try to pick the conversation again. And this is possible when you wait some seconds and then the voice assistant can ask again. And when the user doesn't answer again, then you can break the conversation. The response should build like a human, so don't answer with only words, answer with a complete but shortened sentences. And you can use past behavior. So when you, for example, when you develop a skill for a pizza service, and you have a user which always orders pizza salami, so then it makes sense to ask the user at the beginning of the conversation, do you want the pizza salami again? And not asking always, do you want a salad, do you want pasta or whatever. And on each point of the conversation, you should be able to provide help. So when the user doesn't ask for help, you should give him an overview about the current conversation and give him the information what the assistant is currently expecting from the user. These are interesting points and you should keep them in mind when you are developing a bigger conversation app. Before we start with the technical stuff, everything which I told you today can be tried out with smartphones, so you don't need to buy a device. Both assistants, the Google Assistant and Amazon Alexa, is available on smartphones too. So you can try everything with the smartphone. Okay, then let's start with the Alexa ecosystem. The Alexa ecosystem is really big and very powerful. And this ecosystem contains two powerful frameworks. This side, the right side, has the Alexa voice service. This is a framework which allows you to build own devices which are enabled for Alexa. So for example, when you have a Raspberry Pi at home, you can plug in a microphone and build your Alexa device completely by your own. Of course, the microphone is not comparable to the microphone array which is used in the Amazon Echo, but it works. And this is an interesting topic because on the CES, the Customer Electronics Show in Las Vegas, many companies presented devices which are enabled Alexa. The automobile industry, for example, will integrate Alexa in the future in their cars, which is a very powerful use case. But I don't want to talk about this side because I don't want to buy my own device. I want to enhance the existing devices with a new Skil. So we are on this side here today, the Alexa Skills Kit. This is the framework which allows me to build new skills, and there are different kinds of skills. There is a custom skill, or a skill for smart home things, or flash briefing skill. The newest category is the video skill. This is for devices which have a display. This is very new and only available since some months. I doesn't have such a device, and I will concentrate me today on the first three categories, which are the most important ones, in my opinion. So, let's start with the custom skill. The custom skill is the most flexible skill which is available and allows you to build a real conversation. So the human is asking something or the device is asking something, or the other way. The flow is the following. The user is asking the device is sending the audio stream to the cloud, the Alexa voice service. Maybe you remember, this is the framework which enables the device to the Alexa logic, to the Alexa brain. And this cloud and this framework analyze this audio stream and triggers the correct commands. In our scenario, we are asking for our skill, so the Alexa voice service will trigger our skill. And within the skill configuration, there is an endpoint defined. And this endpoint is responsible for the logic, for the source code. And for an endpoint, I use AWS Lambda. Maybe some of you remember AWS Lambda was already on topic of League of Geeks in November, presented by Otmar. And I will use this service because it's really recommended to use this service, and it's a very powerful service. For everyone who was not part of the November League of Geeks session, Lambda is an AWS service which allows me to build functions with source code in different program languages, and these functions can be triggered by an event. And there are multiple events possible and supported by Lambda. An event can be maybe a change in the database or a change in the file system, but also a call of a REST service, for example. And in our scenario, the trigger will be an Alexa Skills Lambda trigger. So the skill triggers the Lambda function. The Lambda function has the source code and the logic, do something, give a response, and it goes back. Before we can implement our stuff in AWS Lambda, we have to define the interaction model for this skill. The interaction model contains three elements. It contains intents. An intent is always one action. You can have multiple intents, but one intent is always one action. And an intent fulfills always the user-spoken request. An intent can have arguments, parameters, and there are different kind of intents. So intents which are defined for the developer, for business logic, and built-in intents for standard commands like stop, which are defined by Amazon itself. Then the next thing is utterances. Utterances are the spoken phrases which are mapped to intents. As I told you before, Some people are asking something, and some people giving commands. These are two different phrases which are mapped to the same intent, to the same action. You should support as many phrases as possible. And the last thing are slots. These are the arguments of intents. For example, when you say, tell me the weather of today. Today would be the argument, because you can also say, tell me the weather of tomorrow. And these are the parameters. There are custom slot types, when you want to define the type completely by your own, but also built-in types possible, like, for example, dates. This is a built-in type you can use, and it is defined by Amazon. So, what do you have to do when you create a new skill? When you create a new skill, you have several steps you have to configure. In the first step, you define which kind of skill is it. Here we have a custom skill. So we have here skill type custom. Then we define the language of the skill. Each skill always supports only one language. The name of the skill and the invocation name. The invocation name is very important because it's the name how the user can trigger your skill when he wants to use it. On the next step, there is the interaction model I was talked about. In this section, you define the intents, so the actions which are supported by the skill. In this example, this is a skill for a pizza service. And here I have an intent pizza order. This intent have a slot, so an argument. Which pizza does the user order? Here is the slot definition. And here we have defined salami, cheese, or pepperoni. And in the last section, there are defined the utterances, so the phrases which can be handled. And here you have, in the first, is the mapping to an intent. So here is the intent definition, pizza order. Here is it mapped to a phrase. So the user can say, send me a pizza, and then the argument, send me a pizza salami, for example. And now we have defined what can the skill do, or what can the skill handle. And now we need an endpoint for the program logic. Here we define which endpoint type do we have. Here we are using AWS Lambda because it's a very powerful service. You can also use another endpoint which is reachable via an URL, so via HTTPS. But in my presentation I will always use Lambda. So here we are entering the address of the Lambda function, and that's it. In the next step, the test section, we only just activate the skill for testing, and now it is it. And we can use this skill in our devices. So when I have an Amazon Echo here, I could test my skill now. The last section are only for publishing things. So when I want to publish the skill for the world, I have to document it, define a short description, define a logo, and so on. Define the privacy stuff. But when I only do the first 4 sections, I can use my skill for my own. Okay, now we have created our skill. We have implemented the Lambda function. And how we can trigger this skill now. There are different kinds of invocations. The direct conversation just started the skill. So we can say Alexa and then the invocation name of the skill. In our example, for example, Alexa, Pizza Luigi. Pizza Luigi is the invocation name of our skill. These are some examples, and you can also say Alexa, begin Pizza Luigi or launch Pizza Luigi. There's another possibility to, when you want to trigger the skill, give him an intent or a phrase. This would compress the conversation because you trigger the skill and trigger an invocation in one sentence. So you can say Alexa, then the phrase, and then from invocation name. So for example, Alexa, I want a pizza salami from Pizza Luigi. In theory, this kind of invocation is very powerful. In the practice, it's not always recognized correctly by Alexa, and sometimes you need a second try to that Amazon understands you. So the best way is to use direct invocation. Says, Alexa, open Pizza Luigi. Then the skill is triggered and the skill would say, hello, I'm the pizza service. And then you can say, I want a pizza salami. This is a better handling in my opinion, because in the practice this doesn't work so good. So, what I explained to you now was the custom skill. This skill is a very flexible skill because, as I told you, you can build a real conversation. But it has some disadvantages. You always need this invocation name. And this makes it really unnatural to talking a skill. There are other kind of skills, like the flash briefing skill. This is the most easiest skill and I like it very much. The flash briefing process of Amazon Alexa is the following. In the Alexa app, you just activate some flash briefing skills, and all activated flash briefing skills are listed in the flash briefing configuration in the settings. Here the user can reorder the skills, and then the user can start the flash briefing process only via saying, give me my flash briefing. And then the process is started and Alexa would trigger the first skill. This skill would inform the user. It's not possible to ask this skill something. The skill is only triggered and the skill is to inform you something about news. When this skill is finished, the next skill would inform you about his stuff. But it's very powerful for news. And it has some positive effects. You doesn't need to define an interaction model because you doesn't need phrases. You only say, give me my flash briefing. You don't need to define an invocation name. And what is really cool is, normally you doesn't need to program something. You can only configure it and reference to an RSS or XML file. In the practice, it's not always so easy because many RSS files are not optimized for speak out something. So some RSS file contains links, for example, and it would sound really stupid when Alexa tries to read or speak out this link. So in the practice, you have to transform this RSS file and optimize it for voice. It has some negative points, and the negative thing is the limited flexibility. Because you can't define different intents, and so you can't ask the skill something. The skill is only for informing you. And it's not possible to trigger one of the skills individually. So the user can only trigger the flash briefing process, but he can't trigger the second skill standalone. That's not possible. But nevertheless, I find the skill very helpfully because it can be triggered by a standard command. Tell me my flash briefing. This is a standard command and is very, very well supported by Alexa. The invocation names are not always so good recognized as the standard commands. The next thing is a smart home skill. This is the most complex skill, but when you look in the Alexa app, the most popular skills for Alexa are always smart home skills. The positive thing is you also do not need an invocation name, because smart home devices are supported very well, and within the Alexa app on your smartphone, you can say search for devices, and then Alexa asking all smart home skills, give me your devices, and the devices are listed here. And then you can control these devices only by Alexa, set living room off. You don't need an invocation anymore. For example, when, let's say, Philips Hue, for example, when they would implement a custom skill, then the user would always need to say, Alexa, tell Philips Hue, it's the invocation name, turn my light off. This sounds really unnatural. When Philips Hue implement a smart home skill, it's possible to say, Alexa, turn living room off. So no invocation name is necessary. Also, no interaction model is necessary because the phrases for lights or smart home things are always identical. So the interaction model and the phrases which are supported are defined by Amazon itself. The negative thing is, most examples for smart home skills are outdated because Amazon reworked the SDK. And yeah, the first step for implementing such a skill is a little bit tricky. And the next thing is, account linking is obligatory. So when the user wants to activate the skill, he has to needs some credentials to link it to an account, which definitely makes sense when we think about, because when we compare it to a flash briefing skill, and me and a colleague, both of us would activate the same skill. Then both of us would receive the same information from this skill. And for this category, it definitely makes sense. But for a smart home device, if me and my colleague would activate the same skill, we doesn't want to control the same lights. When I say turn the living room light off, I want to control the living room in my house. And the other person wants to control his living room. So therefore, when you activate the skill, you have to link it to an account. Then there's some additional stuff. You can improve the speech from Alexa by using SSML tags, speech synthesized markup language. And there are some tags which helps you to tell Alexa that she has to pronounce something special. For example, MSG is not a word. So when Alexa is talking about MSG, she should speak out each letter individually. The next things are dates or telephone numbers. A telephone number is a large number, and Alexa shouldn't speak it out like 1,321,000 or something like that. So here we can use these tags to make it better. There are a lot of SSML tags. These are only some examples. There are also speech counts. These are special words which are pronounced very specially. These words are defined by Amazon, and there's a big list of special words. For example, when I want that Alexa is saying something, when I look to Alexa skills, I just have to say Basinga. Basinga is a special word and should be pronounced a little bit special. Here I can use also this text. A next powerful feature are cards. As I told you at the beginning, the spoken response of an Alexa skill should always be very shortly. When you have a skill which allows the user to order a taxi, and the user tells, send me a taxi at 8 o'clock, then the device can say, okay, understood, I send you a taxi. But it's possible that the skill creates a card in the Alexa app, and this card contains detailed information. A card can contain a picture, a title, and text and detailed information like payment or the address. These cards are persisted, so when the user orders a taxi, 1 hour later he can look to the smartphone and has the confirmation with the detailed information. When you want to persist something in your skill, it's also very easy. Of course, it's your code and you can do it like you want it. But for here, Amazon Dynamo database tables, Dynamo database is also a service from AWS, are supported very well here. And with only 2 lines, you can persist something. This is helpfully when you want to use the past behavior of a user. So only just define the name of the database table and this line to save something, and when the skill is triggered again, you have this information out of the box. and you can use it. This makes it really simple. So, before we start with the first live demonstration for Alexa, we have some preconditions. What do we need? We need an Amazon developer account. This account is completely free and you can use the same credentials as in your normal Amazon account. Then you need a backend. As I recommend, I would use AWS Lambda. For this you need an AWS account. This is also completely free and you only pay what you are using. For AWS you have for almost all services a free tier in the first 12 months. So it's possible to experiment really a lot without paying something. And Lambda has a permanent free tier. So also after the first 12 months, you have 1 million requests completely free. So this is what I wanted to say at the beginning, to say hosting a skill would lead to cost for me as a developer. This is a theoretical problem because 1 million requests are a lot, especially for voice recognition. And even if you have multiple users, to reach this free tier, 1 million tree is very optimistic. And even if you come over this layer, AWS Lambda is a very cheap service. So we are talking about cents or less euro, not a big amount. When you want to use Lambda, this is an important information, AWS has different regions in the world. But only 2 regions from AWS supported Alexa Skills. So you have to host or implement your stuff in Virginia or Ireland. AWS also have a region for Frankfurt, but you can't use them when you want to develop an Alexa skill. Okay, then to finish the Alexa stuff, let's make a short live demonstration. I prepared a very easy example. What I said is, we need an Amazon developer account and an AWS account. On this register card, this is my Amazon developer account. Here I can click to Alexa. I can click to Alexa. Then I have 2 frameworks. This side would be the Alexa voice service, but today we are talking about the Alexa Skills kit. I just click this button and I get a list from all skills I have developed. And I see the name, the language of the skill, the type of the skill. Is it still in development or is it already published? I can check metrics, how much user does the skill have. And I prepared a skill for my pizza service. The first step as I created this skill was that the portal is asking me which kind of skill do you want. I selected custom skill because I want to make a conversation skill. Then I defined English as the language, the name of the skill and the invocation name. On the second section, I defined my intents. It's a JSON format, the pizza order intent with the parameter, an intent for sandwich. This doesn't have any parameters. The built-in intent for providing help or stop. These are built-in intents. Here are my pizzas defined, and here is the mapping to phrases. So, in the first section I defined an intent pizza order, and I have mapped it here and here. 2 different phrases mapped to the same intent, and the intent have an argument. I also do support I want a sandwich. This is a really hello world example, but I want to short the example to explain you how easy it is. In the configuration, I defined my endpoint. Here I say I want to use Lambda as a service, and I define here the address of the Lambda function. So, now we need a Lambda function. To make it shortly, because it was already presented by Ottmar, I switched to AWS account. Here I have all services from AWS, but we only need Lambda. Here are all my functions. I can search for something. I have already created a Lambda function for my pizza service. I could create here a new one. And when I'm within one Lambda function, I see the triggers which can be trigger my Lambda function. Here, the trigger is the Alexa Skills kit. And here below, you see the source code. And for my really hello world example, this source code is completely enough for a working Alexa skill, which defines in the Alexa SDK the individual handlers for my intents. And here are the individual handlers. Here I have a handler for my intent pizza order. And everything which I implemented here is executed when I'm saying I want a pizza salami. I have only one line here, and I only just say, okay, I sent you a pizza. In the practice it's a little bit complicated, but I only wanted to show you how easy it is. I can say, just tell what leads that after saying this, the skill is ended, so the conversation ends. I can also say, ask. This would lead that Alexa is saying this, but waiting for an answer. And that's it. And here, at the top of the Lambda, here is the address of the Lambda function. I just copied to this line and entered here. On the next section, I just enabled this one, enabled, and now my Alexa skill is available for my devices, for my Amazon account. When I look on the smartphone to the Alexa app, or using the web portal, I can click to Skills, My Skills, and here is a section, Developer Skills. And here is my pizza service. That's it. I can ask my Amazon Echo at home, I want a pizza salami. He will say, I sent you one, but he will not because it's a dummy. But this is it. This was an example for a custom skill, when you want to build a conversation. There are other kind of skills, like flash briefing. I want to show this one. I have, for example, some of you knows the blog Stadt Bremerhaven, Cash's blog. Maybe some of you knows it. I have implemented a skill for this. And I just have to fill this out. An interaction model is not necessary because the flash briefing functionality doesn't need intents or phrases. In the configuration, I created some feeds and I have reference to an XML file. And that was it. That's my skill. I couldn't use the existing RSS files from Cash's blog because it was not optimized for speech, but I have implemented a daily job which reads the file, transform it, save it on my AWS storage, and I referenced it to here. Okay, that's everything what I want to tell you about Amazon Alexa. Now I have some slides for the Google stuff. Okay. So, sorry. When you want to develop an app for Google Assistant, you can do it completely by your own by using the Amazon SDK, the Action SDK, or you can use tools. Google has one very powerful tool, which is called Dialogflow. Dialogflow was previously a startup which was purchased 2016 by Google. It was previously called APAI. This is a name which you can find in various YouTube videos. And this powerful tool allows you to build conversational apps, like chatbots or voice assistant apps. The flow is similar to Alexa. So here is the flow from the Alexa skill. It's similar. The user is asking something, the device is sending the audio stream, the cloud is analyzing it, and here we are in the Google world. We can use Google Cloud Functions for Firebase. This Cloud Functions for Firebase is a similar service as AWS Lambda. It's only Google's cloud solution. For me, I doesn't want to use Google Cloud Solution because I'm really happy with AWS. And when I develop something, I develop it at first for Alexa, and then I want to develop it for Google. But I don't want to use two different cloud solutions. That's my opinion. So I can use Lambda as well for a Google Assistant app. But a Lambda function always needs a trigger. The Lambda trigger for an Alexa skill was the Alexa Skills kit. Here we want to trigger the Lambda function from outside, because this is the Google Cloud, and we want that the Google Cloud triggers our Lambda function. We can use AWS API Gateway. This is an AWS service which allows us to have an URL, and with this URL we can trigger the REST service, our Lambda function. As I told you before, Dialogflow is not restricted to Google Assistant. It's a very powerful tool which can also develop chatbots for Twitter, Facebook, Skype. The list is very long, so I wanted to show you this. There is also an icon for Amazon Alexa. And at first I thought, hey, wow, that's cool. But it's more a marketing gag in my point of view, because it's not really integrated. When you click to this icon, it's just exporting all the configuration stuff from Dialogflow to a zip file, and you can copy-paste this stuff to your Alexa skill configuration. That doesn't make sense. But okay. The other platforms are very, very well integrated. Another difference between an Alexa skill and a Google Assistant app is that Google supports more powerful visual elements. They have also cards. Alexa, of course, has also cards, but the cards of Google Assistant can be more complex. It can contain borders, buttons, titles, and so on. It can be a little bit more. You can also implement selectors, where you can choose something, or you can use suggestion chips. So when you're talking to your assistant, the assistant can give you some suggestions, and you can just click to it. So you can mixture to talk to the assistant or using the screen. Of course, these features can only be used when you have a device with a screen. Google Home, for example, doesn't have a display, but you can use it. Okay, then let's take a short look to Dialogflow. When you log into dialogflow.com, you can use your Google credentials, and then you just click Create a New Project, and then you are on this screen. On this screen, you can define your intent. It's very similar to an Alexa skill. You can create here a new intent. Then you define your phrases, which you are supporting. You can use parameters. These are defined here. And the possible values of this parameter, here pizza is an entity. Here I have my supported values configured. and I can also configure the response. So I can develop really simple and Google Assistant app. And I can test it here on the right side, and I can say, I want a pizza salami. And the response of the assistant will be, sure, I will send you a pizza salami. That's it when you have fixed responses. But in practice, you will need some source code to do something. So you can use fulfillment here. On the fulfillment, you can enable the webhook, and you can enter an URL, which is always triggered when the intent is called. And the request, when this is triggered, contains a body, and in the body of the request, there is which intent was triggered, and you can use this information and do your stuff. This URL is an URL I have from AWS API Gateway because I wanted to use AWS. But you can also use Cloud Functions for Firebase. You can just use this one, and here you have some example code and a code inline editor, and you can do it with this solution too. It's only my way. Okay. Then on the intent side, for pizza order, I doesn't have enabled the fulfillment here. So I have a fixed response. For the other intent, create sandwich, for example, I have checked this checkbox. And when this checkbox is enabled, the URL is triggered, the request is sent when this intent is called. And when I say here, I want a sandwich, I doesn't get the response of here. I get, sure, prepare the money. This is the response I developed in my backend. When you look back to the Lambda functions, I have a Lambda function for my Google Cloud app, Google Assistant app. And it's also very, very easy. Give me a second. Sorry, thank you. Here, you just have your handler function for this Lambda. And here is a lot of commented code. But for a simple response, you just have to develop one line of code, which says speech, and then what the assistant should speech. That's it. When you have multiple intents here, which are using the webhook, you have to use in your Lambda function an if statement which says, if this intent do this, and if the other intent do that. But it's really, really simple. This is an example when you want to create a rich response, so cards, for example. You can build an object, for example here, basic card, define a title, define a sublime title, or images, buttons, and that's it. There are a lot of examples in the web, and it's really easy to do it. When you have configured this stuff on Dialogflow here, you just need the integration step to enable it for Google Assistant. Here in the integration step, you can enable it for Facebook, for Slack, for Twitter, and so on. When you want to use Google Assistant, you just click to this button and say, Manage my app. And I jumped from Dialogflow to the Actions on Google portal. As I said at the beginning, you can implement a Google Assistant app completely by your own by using Actions on Google. Or you use Dialogflow. when you're using Dialogflow, an Actions on Google project is generated. Here you just have to fill this stuff out. For example, which language do I have? Which app name do I want? Which logos do I need? And so on. And when you have filled out the stuff, you can submit it for review. Then it's sent to Google. If Google accepts it, it's published for everyone. Before you published it, you can use test draft and test it either then you come to the simulator, and this is a simulator for Google Assistant. And you can test it either in the simulator on your smartphone. It's also available for all smartphones which are connected to this Google account. And here you can change the language to English. Can say talk to and then the app name. An annoying thing is on Google Assistant, when the app is not published and I trigger this app, it's always saying, alright, getting the test version of this app. This is annoying when you want to use it only for yourself and don't publish it. This is much better for for Amazon Alexa in my point of view. You can say, I want a pizza salami, and it's triggered. That's it. So it's really simple, and yeah, it really makes a lot of fun. Okay. This were my live demonstration. I can't make it really with real devices because my account, my Amazon account, for example, is a German account. And when I develop here an English Skil, it's not available on a German account. So when you want to buy an Amazon Echo, you can only use German Skils, not English Skils. And this is the reason why I have to use the simulator on this presentation. Okay. Are there any questions? Yes.
In a few slides before, you told that you can enter the phrases.
Mm-hmm.
So I'm just interested, is it exactly the perfect matching of the phrases, or is there some kind of intelligence which can mix them up? Because I was wondering if you told so that if I do have to prepare all the phrases that are possible, that would end up in a mass of phrases.
You're right. There is an intelligence behind,
okay,
but you should define many phrases to make it more intelligent. When you only define one phrase, the intelligence is not really big.
So if you can go back to, I think it was in the Alexa slideshow, where there was
here the interaction.
Yes.
Sorry for that. Yeah, yes.
So there's a pizza order, send me a pizza item.
Yeah.
If I would say, please send me a pizza item, it would work. Okay, then good to know.
Yeah. Okay. Any other questions? Okay. Then I think we are finished.
All right, thank you very much.
Yeah.